Welcome to Unacademy Ascend YouTube channel. This is Umamaheswara Rao. One important announcement. Unacademy is starting new batches for GATE 2022. Commences from 28th December. Batch A in Mechanical Engineering. Batch A in Civil Engineering commences from 28th December. A batch in Electrical Engineering commences from 21st December. A batch in Electronics and Communication Engineering starting from 21st December 2020. Unacademy is starting Ascend batches for 2023 GATE. Starting date 28th December 2020. Use code KUR75 to avail 10% discount. Civil Engineering Batch A commences from 28th December 2020. Ascend batch in Electrical Engineering for GATE 2023. Starting date 21st December 2020. Ascend batch for GATE 2023 commences from 21st December 2020. Use code KUR75 to avail 10% discount. Good evening, Rishabh. Today I'll be discussing conditional probability and Bayes theorem. In basic theory of probability, one of the important topic, conditional probability and Bayes theorem. Definition: the conditional probability of an event B given A. The conditional probability of an event B given A is denoted by probability of B by A and is given by probability of B by A equal to probability of B intersection A by probability of A, provided that probability of A is non-zero. The conditional probability of an event B given A is denoted by P of B by A and is given by P of B by A is equal to P of B intersection A by P of A, provided that P of A is non-zero. So, the conditional probability of event B given A means after occurrence of A, we are going to calculate probability of B. After occurrence of event A, we are going to measure chance of B. Let P of E denotes the probability of an event E given that P of A is equal to 1. P of B is equal to 1 by 2. The values of P of A by B and P of B by A respectively are, first option 1 by 4 1 by 2, second option 1 by 2 1 by 4, third option 1 by 2 comma 1, fourth option 1 comma 1 by 2. Observe here, given that P of A is 1, P of B is 1 by 2, then probability of A by B and probability of B by A, given that P of A is 1, P of B is 1 by 2. Now P of A by B is given by probability of A intersection B by probability of B. Now here probability of A intersection B is P of B by P of B, that is 1. Since P of A is 1, that's why P of A intersection B is here P of B. P of B by P of B is 1. That's why P of A by B is 1. Now P of B by A, P of B intersection A by P of A. P of B intersection A is nothing but P of B. That's why P of B by P of A. P of B is 1 by 2, P of A is 1, finally 1 by 2. That's why P of B by A is 1 by 2, P of A by B is 1. Since P of A is, probability of A is 100%, it is a sure event. That's why P of A intersection B is equal to P of B. So P of A by B is 1, P of B by A is 1 by 2. So 1 comma 1 by 2 is the correct answer. Next column. A hydraulic structure has 4 gates which operate independently. The probability of failure of each gate is 0.2. Given that gate 1 has failed, the probability that both gates 2 and 3 will fail is, first option 0.240, 0.200, 0.040, 0.008. A hydraulic structure has 4 gates which operates independently. This is a keyword. Which operates independently. The probability of failure of each gate is 0.2. Given that gate 1 has failed, the probability that gate 2 and gate 3 will fail. Here it is a conditional probability. Gate 1 has failed. It has already happened. Now what will be the chance that gate 2 and gate 3 will fail? You have to calculate probability of gate 2 and gate 3 will fail when after occurrence of gate 1 has failed. So by the definition of conditional probability, G1 intersection G2 intersection G3 by probability of G1, that is each gate operate independently. That's why probability of G1 intersection G2 intersection G3 can be written as P of G1 multiplied with P of G2 multiplied with P of G3 by P of G1. Now P of G1 under cancellation, P of G2 into P of G3, 0.2 multiplied with 0.2, the result is 0.04. So the correct answer is 0.04. Third option is correct. Next problem. An examination. Consists of 2 papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3 and that in paper 2 is 0.2. Given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. Then the probability of a student failing in both the papers is An examination consists of two papers P1 and P2. The probability of failing in P1 is 0.3 and that P2 is 0.2. Given that a student has failed in P2, the probability of failing in P1 is 0.6. A student has already failed in P2, chance of failing in P1 is 0.6. The probability that a student failing in both P1 P2 is in this problem, given that probability of failing in P1 is 0.3. and probability of failing in P2 is 0.2. And also given that, observe here, given that a student has failed in P2, the chance of failing in P1 is 0.6. A student has failed in P2, chance of failing in P1 is 0.6. A student has failed in P2, chance of failing in P1 is 0.6. By the definition of conditional probability, P1 by P2 is P1 intersection P2 by P of P2 equal to 0.6. Continuation. Probability of P1 intersection P2 by P of P2 0.2 equal to 0.6. P1 intersection P2 is by cross multiplication 0.6 into 0.2. Therefore, P1 intersection P2 is 0.12. So the probability that the student failing in both P1 P2 is 0.12. 0.12 is the correct answer. Understood? Next column. Consider two independent random variables x and y with identical distributions. The variables x and y take values 0, 1 and 2 with probabilities 1 by 2, 1 by 4 and 1 by 4 respectively. What is the conditional probability that probability of x plus y equal to 2 by x minus y equal to 0 is option A 0, option B 1 by 16, option C 1 by 6, option D 1. Here, two independent random variables x and y with identical distributions, which takes values 0, 1, 2 with probabilities 1 by 2, 1 by 4, 1 by 4 respectively. So here x takes values 0, 1, 2, y takes values 0, 1, 2. With probabilities 1 by 2, 1 by 4, 1 by 4. Now, we have to find out probability of x plus y equal to 2 by x minus y equal to 0. Now, after happening of x minus y equal to 0, you have to measure chance of x plus y equal to 2. That is, probability of x plus y equal to 2 intersection x minus y equal to 0 in the numerator. Because probability of b by a is probability of b intersection a by probability of a. That's why. Denominator is probability of x minus y equal to 0. 1 minute. Probability of x minus y equal to 0 means you have 3 cases. Probability of x minus y equal to 0 is possible in 3 cases. What are the 3 cases? Probability of x equal to 0, y equal to 0, or probability of x equal to 1, y equal to 1, or probability of x equal to 2, y equal to 2. In all these 3 cases, x value minus y value equal to 0. X minus y equal to 0 is possible only when x and y take same value, right? X takes 0 and y takes 0, then 0 minus 0 is 0. X takes 1 and y takes 1, 1 minus 1 is 0. X takes 2 and y takes 2, 2 minus 2 is 0, right? But in the case of numerator, x plus y equal to 2 and x minus y equal to 0 intersection common. X value suppose 1, y value 1, x value 1, y value 1, then 1 plus 1 is 2, 1 minus 1 is 0. So, the common values which are satisfying both x plus y equal to 2 and x minus y equal to 0 is x equal to 1 and y equal to 1. That's why numerator is probability of x equal to 1 comma y equal to 1. In this problem, it is given that two independent random variables, when x and y are independent, probability of x equal to 1 comma y equal to 1 is nothing but probability of x equal to 1 multiplied with y equal to 1 by probability of x equal to 0 multiplied with y equal to 0 plus x equal to 1 multiplied with y equal to 1 plus x equal to 2 multiplied with y equal to 2. Now probability of x equal to 1, probability of x equal to 1 by 4, y equal to 1 by 4, 1 by 4 multiplied with 1 by 4 by x equal to 0, y equal to 0 means 1 by 2 multiplied with 1 by 2 plus x equal to 1, y equal to 1 by 4 multiplied with 1 by 4, x equal to 2 multiplied with y equal to 2, 1 by 4 multiplied with 1 by 4. By simplifying this, we will get 1 by 16, 1 by 4 plus 1 by 16 plus 1 by 16. By simplifying this, we got 1 by 16 by 4 plus 2, 6 by 16. Final answer is 1 by 6. 1 by 6 is the answer. Next problem. A screening test is carried out. A screening test is carried out to detect a certain disease. It is found that 12% of the positive reports and 15% of the negative reports are incorrect. Assuming that the probability of a person getting positive report is 0.01. The probability that a person tested gets an incorrect report is probability that a person tested gets an incorrect report is 0.0027 0173 1497 2100. A screening test is carried out to detect a certain disease. It is found that 12% of the positive reports and 15% of the negative reports are incorrect. Assuming that probability of a person getting a positive report is 0.01, the probability that a person tested gets an incorrect report, probability that a person tested gets an incorrect report a person tested gets an incorrect report is. Now, a person is selected at random. He may get positive report or he may get negative report. The chance of getting positive report is 0.01. Therefore, so 1% chance to get positive report means 99% chance to get negative report. The report may be correct or may be incorrect. In the case of positive reports, 12% of the positive reports are incorrect. 15% of the negative reports are incorrect. 12% of the positive reports are incorrect. 15% of the negative reports are incorrect. 12% of the positive reports are incorrect means 88% are correct. 15% of the negative reports are incorrect means 85% of the negative reports are correct. Now, the probability that a person tested gets an incorrect report is, randomly if you select one person, what is the probability that the person gets an incorrect report? So here you have two possibilities. The person may get positive report, that positive report being incorrect. A person may get negative report, that negative report being incorrect. So these are the two cases. That means the report is positive and that report is incorrect. The report is negative and it is incorrect. So 0.01 multiplied with 0.12. 0.99 is chance of getting negative report. That negative report is incorrect means 15%. Therefore, 0.0012 here 0.1485. So the person tested gets an incorrect report either by this way or by another way. There are two ways. So first way 0.0012 R means plus 0.1485, either first way or second way. That's why 0.1497. So the correct answer is 0.1497. .1497. Understood? Next one, Bayes theorem. If E1, E2, En are n mutually exclusive events in the sample space S such that S is union I equal to 1 to n ei and A is any arbitrary event in S, then probability of EI by A equal to P of EI into P of A by EI by sigma I equal to 1 to N P of EI into P of A by EI E1, E2, E3 and so on En. A is any arbitrary event in the sample space S. I'll explain by taking one example. The probability that a student knows the correct answer, a student knows the correct answer to a multiple choice question is 2 by 3. If the student does not know the answer, then the student guesses the answer. The probability of guessed answer being correct is the guessed answer being correct is 1 by 4. Given that the student has answered the question correctly, the student has answered the question correctly, the student has answered the question correctly, the conditional probability that the student knows the correct answer is, the student knows the correct answer is the probability that a student knows the correct answer to a multiple choice question is 2/3. If the student does not know the answer, then the student guesses the answer. So here, knows the answer and guesses the answer, both are mutually exclusive events. Knows the answer, student knows the answer, student knows the correct answer, and student guesses the answer. Both are mutually exclusive events. So, the sample space is covered by two mutually exclusive events. One is knows the answer, another one is guesses the answer. Whenever student does not know the answer, then only he is going to guess the answer, right? So student knows the answer 2/3, so guesses the answer remaining 1/3 automatically. Student knows the answer is 2/3, student guesses the answer is 1/3. Answer correct is an arbitrary event. If the student knows the answer, it is 100% correct. If the student guesses the answer, the guess being correct is given by 1/4 here. If the student guesses the answer, the probability of guessed answer being correct is 1/4. That's why I have written 1/4. What is the meaning of that? In the question, in the multiple choice question, there are 4 options. Out of 4 options, 1 option is correct. If the student selects that option, automatically by luck it is correct. So 1/4 is the probability that the guessed answer being correct. And now we have to calculate. We have to calculate conditional probability. We have to calculate probability. Probability that the student knows the correct answer. We have to calculate student knows the correct answer. The probability that the student knows the correct answer when given that the student has answered the question correctly. Given that, this is keyword, given that the student has answered the question correctly. Suppose the student has answered the question correctly, what will be the chance that the student knows the answer? We have to calculate probability that the student has answered correctly, then the conditional probability that student knows. That is, we have to write 2/3 multiplied with 1. 2/3 is probability that student knows. If the student knows the answer, the probability that it is correct, that is 1 by 2/3 into 1 plus 1/3 into 1/4. That is 2/3 by LCM 12, 3 4 4 2 8 plus 1 9. 2/3 into 12/9. 3 4 12, 4 2 8, 8/9. Now the correct answer is 8/9. Eight by 9 is the answer. Next column. in a given day, in the rainy season, it may rain 70% of the time. If it rains, chance that a village fair will make a loss on that day is 80%. If there is a rain, the village fair will make a loss on that day is 80%. However, if it does not rain, the chance that the fair will make a loss on that day is only 10%. If there is a rain, loss is 80%. If it does not rain, loss is only 10%. If the fair has not made a loss on a given day in the rainy season, what is the probability that it has not rained on that day? First option 3/10, second option 9/11, third option 14/17, fourth option 27/41. In this problem, rainy day and non-rainy day both are mutually exclusive events. It may rain 70% of the time. So it may not rain remaining 30% of the time. Therefore, if this is 0.70, that is 0.30. Now, in the data it is given that if there is a rain, loss is 80%. However, if it does not rain, loss is only 10%. So I am not taking loss as an arbitrary event. The reason is, the question is designed in the way that the fair has not made any loss on a given day. The fair has not made any loss on a given day in the rainy season. What is the probability that it has not rained on that day? That's why I am going to take gain as an arbitrary event. If there is a rain, loss is 80%, so gain is 20%. If there is not rained on that day, loss is only 10%, so gain is 90%. Now, if there is a gain, what is the probability that the gain came from non-rainy day? Gain came from non-rainy day. That is our question. Non-rainy day, right side part of our diagram. So outer value 0.30, inner value 0.90. This is numerator. Now denominator 0.70 multiplied with 0.20 plus 0.30 multiplied with 0.90. Numerator is 27, denominator is 41. 27 by 41 is the correct answer. Understood? Next column. The chance that a student passing in exam is 20%. The chance of a student passing the exam and getting above 90%, above 90% of the marks is 5%. Given that a student passes the examination, the probability that the student gets above 90% marks is 1 by 18, 1 by 4, 2 by 9, 5 by 18. Yeah, it is a problem designed on conditional probability. Let us take event A is student passes the examination. B be the event that student gets above 90%, above 90% of the marks. Now we have to find out, if the student passes the examination, what will be the chance that the student gets above 90%? So probability of B intersection A by probability of A. Probability of B intersection A is 5%. So 0.05 by probability of A is 20%. That is 5 by 20. That is 1 by 4. That is 0.25. So the correct answer is 0.25. That is 1 by 4. Understood? In Unacademy Plus, we have live classes, crash courses, weekly tests, separate doubt solving sessions, rank improvement batches in both English and Hindi medium. Apart from Plus courses, we have Iconic subscription program. In Iconic subscription, additional benefits: personal coach, study planner, study booster sessions, personalized test analysis, preparatory study material. Additional benefit of Plus course is, additional benefit of Iconic subscription is preparatory study material, personal coach, study planner, study booster course, and personalized test analysis. Use code KUR75 to get 10% off, whether it is Plus subscription or Iconic subscription. GATE and ESE category pricing plan for 1 month subscription. Use code KUR75 to avail 10% discount. This is 1 month subscription. For 6 months, 12-month subscription, 18-month subscription, and 24-month subscription. 12 months, 18 months, and 24 months. Use code KUR75 to avail 10% discount. This is the original price. By using code KUR75, you will get 10% discount. Thank you.